This is we're doing section 6.3 today. And I'm just going to call this what makes a parallelogram. So for today, all of these things we're starting with, or we're talking about, we're saying we're starting, all we know that to start with is that we have a quadrilateral. So we're going to say for all of these that, and I'll grab the picture here for a second, AC, DB is a quadrilateral. Oh, thanks. So let me grab a picture here of the first couple, and what we're going to do is talk about, if we have a quadrilateral, what things guarantee us that our quadrilateral is a parallelogram. So this is kind of like what we did with triangles, where we started by saying, how do we know when polygons are congruent? We said polygons were congruent when all the corresponding sides and all the corresponding angles were congruent. And then we came up with some shortcuts, side, angle, angle, that kind of thing. Well, here we're saying if we start with a quadrilateral and we don't necessarily know right away that it has two pairs of parallel sides, what other things guarantee us that this quadrilateral is a parallelogram? So that's what the whole point of what we're talking about today. And we're saying for all of these that ACDB is a quadrilateral. That's all we know to start. So the first on all these are theorems. We can use these theorems now to do proofs, to justify things, to figure out things about other shapes, to solve problems, that kind of thing. So our first theorem: if two pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And so on our figure, what we could do is mark it like so. If these are congruent, these two are congruent, and those are congruent. So we're saying if we wrote in symbols, segment AC is congruent to segment BD, and segment AB is congruent to segment CD. So if both of those things are true, then we are guaranteed that that shape is a quadrilateral, a parallelogram. So on the opener, we started out knowing that the sides were parallel. Here we don't know the sides are parallel. All we know is we have a quadrilateral. Well, if their opposite sides are congruent, then we're guaranteed that we have a parallelogram. The next one: if an angle of a quadrilateral is supplementary. Supplementary means they add to 180 with both of its consecutive angles. Consecutive means two in a row along the side. Then the quadrilateral is a parallelogram. So what we could do with that one is do this. And I'm just going to pick one angle. It could be any angle. We're saying that the measure of angle A plus the measure of angle C equals 180, and the measure of angle A plus the measure of angle B equals 180. So if we know that that's true about two pairs of consecutive angles, that guarantees us that our quadrilateral is a parallelogram. So kind of just another way, a shortcut, just like our angle, side, to figure out if we have a parallelogram. Questions on those two? Okay, let's look at the next one. And again, we're starting, this is at the top of your page. I'm just going to write it again because it's not top of this one. We start knowing that ACDB is a quadrilateral. And that's true for all of these. That's all we know to start with. So the next theorem tells us if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And we can mark it on our shape here. So both pairs, so that one is congruent to that one, and that is congruent to that. Both pairs of opposite angles, so we're saying that angle A in symbols congruent to angle D, and angle B is congruent to angle C. This is enough to tell us that that quadrilateral would be a parallelogram. What questions there? So all these little tricks, all these little shortcuts to decide if we have a parallelogram. The next one, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Bisect means what? Cut in half. All right, so let's draw our diagonals. Diagonals go from where to where on our shape? Like this? No? Corner to corner. There we go. And I'm going to call this point in the middle, we'll call that point E. If we want to mark our figure, we could mark it like this. Those would be congruent, and those would be congruent. And if we write it in symbols, we would say segment AE is congruent to segment ED, and segment BE is congruent to segment EC. So that's enough to tell us that we have a parallelogram. Questions there? All right, let me grab the last one we're going to talk about today. So our last one tells us if one pair, our last theorem, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So on our drawing we could mark this, these are parallel with the arrows, and congruent. And in symbols we'd say AC, segment AC parallel to segment BC, BD and segment AC congruent to segment BD. Yeah, it could be any pair, either pair of sides. I just picked those two. So this is enough to guarantee us that our quadrilateral is a parallelogram. So we have several different tools to decide if we have a shape and it's marked up in a specific way, is it a parallelogram? So what do you notice about all of these? We all end up with parallelogram. About our conditions. So look over these that you've written down, and I'm going to scroll back and look over these. Is there something that's similar about all of them? They're all parallelograms. On each set, we have to know two different things. We have an "and" written in each of these. So on each of these, there's two pieces of information that we need to know. That's we have an "and" written in the middle of each one. So there's two things we need to know. We can't tell just from one thing. You have to know about two different things on each of these. But just a little way to think about it. Just noticing that we wrote an "and" for each of our conditions. We had to know this and this, this and this, this and this. So we need to know two things for each of those. Two different pieces of information. It tells us our quadrilateral is a parallelogram. All right, questions on those conditions? All right, so what we're going to do on Friday is talk about, if we know we have a parallelogram, how do we know whether or not we have a rhombus or a rectangle? So today we figured out how we decide if we have a parallelogram. Tomorrow we'll decide if we have a parallelogram, how do we know if it's a rhombus or a rectangle? All I want to do next is we're going to do a few examples using these ideas, and then we'll go over last night's homework. So let's look at a couple of examples. I think it's really nice to be able to figure out all kinds of things about shapes. It's kind of interesting. So here's what we're going to start with here. Here's our drawing. And we're going to say that this is 4y minus 3. This is 2y plus 5. This is 5y. And this is x plus 8. And this question says, for what values of x is this a parallelogram? So we know we have a quadrilateral. We want to say if these sides have these measurements, what would make it a parallelogram? So what do we need to know about the sides of the parallelogram, or the sides of the quadrilateral, for it to be a parallelogram? The congruent. Each pair of opposite sides has to be congruent. So what we need this? No, 4y. 4y minus 3. So what we need is x plus 8 equal to 5y. Those two opposite sides have to be congruent, same measure. And we need these two to be the same. And two pieces, and 4y minus 3 equal to 2y plus 5. So we have these two equations. We have the variables x and y. How are we going to proceed here? What can we do? So it's going to be a systems of equations. And how did we solve, so in this class so far, how have we solved systems of equations? We really only used one substitution. So we want to solve one equation for one variable and substitute it into the other equation. So we want to use substitution. So we have that nice idea to use substitution. So which one is going to be easiest to solve first? The one with the y's, because if we solve this, we can get y by itself, and y is just going to equal a number. So let's solve this one first. 4y minus 3 equals 2y plus 5. This shouldn't be too hard, right? Minus 2y. So we get 2y minus 3 equals 5. Add 3. So 2y equals 8. Divided by 2. And y equals 4. And now we're going to take that y, substitute it right there. So I get x plus 8 equals 5 times 4. So x plus 8 equals 20. Subtract 8. And x equals 12. So if x equals 12, then this quadrilateral would be a parallelogram, because that would make both pairs of opposite sides congruent. Questions there? That one's kind of nice. All right, let's look at a couple more. So for these two, we want to know, is it a parallelogram? And why? So here's my first shape. And these are, all these problems are like the triangle problems that we did. Go by what the problem tells you, not by what the drawing looks like. All right, so what did I just draw in there? The diagonals. And I'm going to mark them like so. So is this shape a parallelogram? Yes? And why? The diagonals bisect each other. So that's enough to guarantee us that this is a parallelogram. How about this one? Is that shape a parallelogram? Yes? We're going to say yes. And why? Okay, is one pair of opposite angles congruent enough to show that we have a parallelogram? Or remember, we had to have two things happen for each situation. But it has to have something to do with angles, right? So what do we know about the angles? What's that?
49 and 131.
These are supplementary. And how about these two? So this one is because an angle is supplementary to both of its consecutive angles. Yes. Okay, so you could, that's another way you could do it by adding a step. So what we said was, we know that a quadrilateral, all the angles inside a quadrilateral have to add up to 360. So if you add these two up, add these three up, subtract it from 360, that tells you that this is 131. And then both pairs of opposite angles would be fine. So what you just came up with would be how we would prove that theorem. That's why that theorem works, is because all the angles have to add up to 360. So based on what we said today, is 131 is supplementary to both the 49-degree angles. So those are both of its consecutive angles. Last one. This one should be really easy, hopefully. And I'm going to label this one. Is this one a parallelogram? This one is a yes. And why is this a parallelogram? Both pairs of opposite sides are equal. So when we're showing things are parallelograms, when we show quadrilateral parallelograms, remember that we always need to know two pieces of information. One piece of information is not going to be enough. We need two pieces of information. Something about two pairs of angles, two pairs of sides, some kind of combination that has two pieces of information. Questions on parallelograms, how we know when quadrilaterals are parallelograms. Okay. Before I pass your folders back, I'll write down our homework for tonight, because we're going to do a few other things, so I want to make sure everybody gets it. So we're on page 386, and we're doing number 8 through 140.